Hi guys, welcome to this IGCSE tutorial on simultaneous equations. The questions in this tutorial are based on 20 past exams. So let's get started. We can solve simultaneous equations by one of two methods, elimination and substitution. We're going to stick to one method, namely elimination, because I believe that it's the quickest way to solve simultaneous equations with. So we have to solve these simultaneous equations. In other words, we need to find the values of x and y that will make both equations true. The first thing to notice here is that the x's in both equations have the same coefficient. The coefficient of x in the first equation is 1, and so is the coefficient in the second equation. So we can start by letting the first equation be equation 1 and the second equation equation 2. Now we simply subtract equation 2 from equation 1. So we have x minus x is 0, so the x's cancel, and 2y minus 5y is negative 3y. Then 13 minus 22 is negative 9. We can solve for y now, and we can get rid of the negative 3 here by dividing both equations by negative 3, or both sides rather, by negative 3. On the left-hand side, the negative 3's will cancel, and we're left only with y. Then we have negative 9 divided by negative 3, which is positive 3. Now that we have the value of y, we can plug it back into any one of the two equations. So let's plug it back into equation 1. So substitute y equals 3 into equation 1. We have x plus 2y is 13. So that means that x plus 2 times 3 is 13. And here we can solve for x. So we can take the 6 to the right-hand side, and 13 minus 6 is 7. So we have the values for both x and y. Now, very important when solving simultaneous equations, we always plug it back into the original equations to see whether the answers work. So let's plug x and y back into equation 1. We saw that x was 7 and y was 3, and 7 plus 6 will give us 13, in other words, the right-hand side. Let's also check it with equation 2. So x plus 5y is 22, and we saw that x was 7 and y was 3, and this does give us 22. So we know that our answers are correct. We have to solve these simultaneous equations. We notice that the coefficients of the y's in both equations are negative 3. So the y's have the same coefficient, and that means that when we subtract the equations, the y's will cancel, and we can solve for x. So we can call this equation equation 1, and the second equation equation 2. We're going to say equation 1 minus equation 2. So we have x minus 2x, which is negative x. Negative 3y minus negative 3y is going to be 0. So it's negative 3y minus negative 3y equals negative 3y, and a minus times a minus is a plus. So negative 3y plus 3y, which is 0. So then on the right-hand side here, we have 7 minus 11, which is negative 4. We want to get rid of the minus here, and this is actually negative 1. Of course, we don't write the 1. So to get rid of the negative here, we can divide both sides by negative 1. And we see that x, of course on the left hand side, the negative ones will cancel, and we're left only with x. And then we'll have negative 4 divided by minus 1, or negative 1, which is positive 4. So now we have the value for x. We can substitute this value back into any one of the two equations. So let's substitute x equals 4 into equation 1. We have x minus 3y equals 7. So that means that 4 minus 3y equals 7. And we can solve for y. We can take the 4 to the right hand side and we'll have 7 minus 4, which is 3. Now we want to get rid of the negative 3 here. So we divide both sides by negative 3. Then on the left hand side, the negative 3's will cancel, and we're left only with y. And then 3 divided by negative 3 is negative 1. So we have both y and x now. Y is negative 1 and x is 4. And once again, we should plug it back into the original equations to see that it works. So x is 4 and y is negative 1. 4 minus 3 times negative 1 will give us 4 plus 3, which does give us 7. Then plugging our answers back into the second equation, 2 times 4 minus 3 times negative 1 will give us 8 plus 3, which does give us 11. When we use the method of elimination to solve simultaneous equations we want either the coefficients of the x's or the coefficients of the y's to be the same. In this case, the coefficients of the x's are not the same. We have a 3 here and a negative 4 here. Neither are the coefficients of the y's because we have a negative 2 in the first equation, but negative 1 in the second equation. We can make either the coefficients of the x's or the y's to be the same. In this case, it will be easier to make the coefficients of the y's the same. And we can do so by multiplying the second equation here by 2. So let's multiply through by 2. So 2 times negative 4x and 2 times negative y. Then we have negative 5 times 2, which is negative 10. Now we see that the coefficients of the y's are the same. And that means that when we subtract the two equations, the y's will cancel. So we can call this equation 1, and the new equation here we can call equation 2. Now we simply subtract equation 2 from equation 1. So 3x minus negative 8x will give us 3x plus 8x, which is 11x. So we have 11x, then negative 2y minus negative 2y. Negative 2y minus negative 2y will give us negative 2y plus 2y, which is 0. So we can see that the y's will cancel. Then on the right hand side, we also have 23 minus negative 10. So 23 minus negative 10. And that of course is 23 plus 10. A minus times a minus is a plus, which is 33. So the right hand side comes to 33. We can solve for x here by dividing both sides by 11. On the left hand side, the 11s will cancel and we're left only with x. And we have 33 divided by 11, which is 3. So now we have the value of y, or rather x. To get the value of y, we can plug x back into equation 1. So substitute x equals 3 into equation 1. So we have 3x minus 2y is 23. So 3x minus 2y equals 23. We simplify. We can take the 9 to the right-hand side. So 23 minus 9 will give us 14. And we can solve for y by dividing both sides of the equation by negative 2. The negative 2's will cancel here. And we have y equals 14 divided by negative 2, which is negative 7. So now we have both the values of y is negative 7, and x is 3. We can check our answers by plugging back into the original equations. So 3 times x minus 2y, 3x, and we saw x was 3 minus 2y, and of course y was negative 7, will give us 9 plus 14, and this does come to 23. Let's plug it into the second equation here. So minus 4 times 3 minus, and y is negative 7, will give us negative 12 plus 7, which does give us negative 5. So in order to use the method of elimination to solve these simultaneous equations with, we need either the coefficients of the x's or the coefficients of the y's to be the same. We can get the coefficients of the y's to be the same by multiplying the second equation here through by 2. So 2 times 5x plus 2 times 2y equals 2 times 21. Now we see that the coefficients of the y's are the same. We can call this equation 1 and this equation 2. Since the coefficients of the y's are the same, the y's will cancel when we subtract these equations. So then equation 1 minus equation 2, 3x minus 10x is negative 7x. 4y minus 4y, of course, is 0. Then on the right-hand side, 14 minus 42 is negative 28. And now we can solve for x. We can divide both sides of the equation by negative 7. The negative 7's will cancel on the left-hand side. And we're left with x only. And of course, negative 28 divided by negative 7 is positive 4. So now we have the value of x. We can get the value of y by plugging x back into the first equation. So it's 3x plus 4y equals 14. So 3x plus 4y equals 14. And we solve. We can take the 12 to the right-hand side. So 14 minus 12 is 2. And now we can solve for y. Y will be 2 divided by 4, or a half. We check our answers. We've got both x and y now. Y is a half, and x, of course, is 4. We can substitute back into the equations. So 3 times 4 is 12. And 4 times a half is 2. And we do get 14. Let's plug it into the second equation. Five times 4 is 20. 2 times a half, of course, is 1. And we also get 21. So here we have a fraction in the second equation. And as a rule, we can always get rid of fractions first. We can get rid of this fraction here by multiplying the second equation by 2. So we're going to get 2p minus 2q. And then 2 times negative a half is negative 1. We see now that the coefficients of the p's are the same. So we can call this equation 1 and this equation 2. And when we subtract the one equation from the other, the p's will cancel. So equation 1 minus equation 2, 2p minus 2p will be 0. Then we have q minus negative 2q. So q minus negative 2q will be q plus 2q, which is 3q. So we have 3q on the left-hand side. Then 2 minus negative 1. So 2 minus negative 1 will be 2 plus 1, which is equal to 3. So we have 3 on the right-hand side. We want to get rid of the 3 here on the left-hand side, so we can divide both sides by 3. The 3's will cancel here, and we're left with q is 3 divided by 3, which is 1. So now that we have q, we can find p by substituting q back into equation 1. So substitute q equals 1 into equation 1. So 2p plus q is equal to 2. We can take the 1 to the right-hand side, so 2 minus 1 will give us 1. And now we can divide both sides by p, or rather by 2. The 2's will cancel here, and we're left with p equals 1 over 2, or 0.5. We can check our answers. We've got both p and q now. So p is a half, or 0.5, and q is 1. So plugging it back into equation 1, 2 times a half is 1, plus 1 is 2. So we do get a 2 here. Then plugging it into the second equation, a half minus q. So a half minus 1 is negative a half, and we also get the second equation. We have a fraction in the first equation, and as a rule, we can always get rid of fractions first. So we can multiply the first equation by 2 in order to get rid of this fraction. So 2 times a half x will be 1x, or just x. And 2 times y is 2y. And that gives us 2 times 8, which is 16. Now we see that the coefficients of the x's are the same in these two equations. So we can call this equation 1, and this we can call equation 2. When we subtract the two equations from each other, the x's will cancel. So equation 1 minus equation 2, x minus x is 0. Then we have negative 2y minus positive 2y. So negative 2y minus positive 2y. is negative 2y. A minus times a plus is a minus. And negative 2y minus 2y is negative 4y. So we have negative 4y on the left-hand side. Then 2 minus 16 is minus 14. Now we want to get rid of this negative 4 here. We can divide both sides of the equation by negative 4. The negative 4's here will cancel, and we are left only with y. A negative divided by negative is a positive, and we can also simplify this fraction. So 14 divided by 2 is the same as 7 over 2. 7 into 14 twice, or rather 2 into 14 7 times, and into 4 twice. And this, of course, is 3.5. So we have the value of y. We can now substitute the value of y back into any one of the equations to get the value of x. So we can plug it into this equation. X minus 2y equals 2. So substitute y equals 3.5 into this equation here, equation 1. So we have x minus 2y equals 2. We can take the 7 to the right-hand side, and it becomes positive 7. So x will be 2 plus 7, which is 9. Now we have the values of both x and y. So x is 9 and y is 3.5. Let's plug it back into the equations. And 9 minus 7 does give us 2. Let's plug it back into the second equation. And this does give us 16. We have a fraction in the first equation, and we can get rid of it by multiplying through by 2. So 2 times y is 2y equals x over 2 times 2. The 2's will cancel here, and we'll be left only with x. We want both our x and y's, or x and y, to be on the left-hand side. So we're going to bring both these to one side. So we get x minus 2y equals 0. Now let's look at the equations. We have 2x minus y is 1, and we have x minus 2y equals 0. We want the coefficients of either the x's or the y's to be the same. If we multiply this equation through by 2, we're going to get a coefficient of x, which is 2 here. So we multiply this equation by 2. Now we see that the x coefficients are the same in the two equations. So we can call this equation 1 and this equation 2. And we can subtract equation 2 from equation 1. 2x minus 2x will be 0. Then we also have negative y minus negative 4y. So negative y minus negative 4y is negative y plus 4y. And this, of course, is 3y. So we have 3y left on the left-hand side when we subtract these two equations. Then 1 minus 0 will give us 1. We want to solve for y here, so we can divide both sides of the equation by 3. So we see then that y is equal to 1 over 3. Of course, these 3's cancel on the left-hand side here. So now we have the value of y. We're going to substitute it back into equation 1 in order to get x. So substitute it back into equation 1. So in equation 1 we have 2x minus y equals 1. So 2x minus y equals 1. We can take the negative third to the right hand side. So it's going to be 1 plus a third, which is 4 over 3. Now we can divide both sides of the equation by 2. So we're going to divide this also by 2. On the left hand side here, the 2's will cancel, and we're left only with x. So 4 over 3 divided by 2. Basically, the 2 goes into the 4 twice, and we see that x equals 2/3. So we have both the values of x and y now. X is 2/3 and y is 1/3. And we should plug back into both equations to see that it works. So 2x, and we saw that x was 2/3 minus y, which was a third, and that does give us 1. Let's plug it back into the second equation, 2x and we get 4 over 3 here minus 4 over 3, which does give us 0. Now, when we solve application problems for simultaneous equations, we always let what we are looking for be x and y. In this case, we're looking for the cost of a notebook and the cost of a pencil. So we can let the cost of a notebook be x dollars and the cost of a pencil be y dollars. Now we can set up simultaneous equations. We know that Robbie buys 3 notebooks and 4 pencils. So he's going to pay 3 times x for the notebooks and 4 times y for the pencils. And this must come to $10.80. Then Penise buys 5 notebooks and 2 pencils. So she'll pay 5x for the notebooks, or 5 times x for the notebooks, plus 2 times y for the pencils. And we know that this must come to $14.50. So $14.50. So we've set up the simultaneous equations and we need to solve it, or solve them. We want at least one of the coefficients of the x's or the y's to be the same. We can easily get the coefficients of the y's to be the same if we multiply the second equation here by 2. So we're going to get 2 times 5x plus 2 times 4y, or rather 2 times 2y. And we also multiply the right-hand side here by 2, and that's going to give us 29. So now the coefficients of the y's are the same. So we can call the first equation 1, and the second equation we can call equation 2. If we subtract these two equations, the y's will cancel. So we're going to say equation 1 minus equation 2. So it's going to be 3x minus 10x, which is negative 7x. 4y minus 4y is 0. So we can see that the y's cancel. And we also have 10.8 minus 29. That we can do in a calculator. and it comes to negative 18.2. We can solve for x here by dividing both sides by negative 7. So the negative 7s will cancel here, and we're left only with the x on the left-hand side. Then on the right-hand side, we know that a minus divided by a minus is a plus. So then 18.2 divided by 7 gives us 2.6. So x is $2.6. So remember we said that x is the cost of a notebook. So one notebook costs $2.60. Now we want the cost of a pencil, and we're going to take this value of x and plug it back into equation 1. So 3x plus 4y is $10.80. So 3x plus 4y, and we solve for y in this equation. So it's going to be 3 times 2.6, which is 7.8. We can take the 7.8 to the right-hand side. So we subtract it from the right-hand side. And we get 3. So 4y is 3. Now we can divide by 4 on both sides. And we're going to be left with only y on the left-hand side. Y is 3/4, which of course is 0.75. So the cost of a pencil then will be $0.75. So here's another question on application problems for simultaneous equations. It says the cost of one ruler is R cents. The cost of one protractor is P cents. The total cost of 5 rulers and one protractor is 245 cents. The total cost of 2 rulers and 3 protractors is 215 cents. Write down 2 equations in terms of R and P and solve these equations to find the cost of one protractor. So let's set up the simultaneous equations and solve them. The cost of 5 rulers and one protractor is 345 cents. So we want to turn this statement into an equation. So we have 5 rulers. Now each ruler is R cents. So we're going to pay 5R or 5 times R cents for 5 rulers. Then plus 1 protractor, and 1 protractor is P cents, so it's just 1 times P. This will be the cost for the 1 protractor. Of course, we could also just write P here. Then according to this statement, the first one here, this must come to 245 cents. Then we have 2 rulers and 3 protractors. So 2 rulers, each of the rulers will cost R cents. So the total cost will be 2R, or 2 times R, plus 3 protractors, and each protractor is P cents. So we'll pay 3 times P, or 3P, for the 3 protractors. So this sum must come to 215. Now we can solve the equation simultaneously. We want either the coefficients of the R's or the coefficients of the p's to be the same. If we multiply the first equation by 3, then the coefficients of the p's will be the same. So let's do that. So we're going to multiply the first equation by 3. So 3 times 5r plus 3 times 1p, or just p, equals 3 times 245. So 3 times 245, that gives us 735. Now the coefficients of the p's are the same, and we can call this equation 1 and this equation 2. Now we subtract equation 2 from equation 1, and the p's will cancel. So 15r minus 2r is 13r. 3p minus 3p is 0. And we have 735 minus 215. And that gives us 520. Now we can solve for r. We can divide both sides of the equation by 13. So the 13s will cancel on the left-hand side, and we're left only with r. So 520 divided by 13, and that comes to 40. So basically 40 cents. Now let's go back to the question. R was the cost of 1 ruler. So we know that the cost of 1 ruler is 40 cents. We were asked to find the cost of 1 protractor. So we want the value of p. So we're going to substitute this value back into the first equation, or even into the original equation. So it says 5r plus p is 245. So 5r plus p is 245. This, of course, is 200. And we can solve for p here by taking the 200 to the right-hand side. So it's going to be 245 minus 200, and this is 45 cents. So then we have worked out the cost of 1 protractor, and it comes to 45 cents.